Hi everyone, and welcome to another video from Erik's Electronics Workbench. So recently I picked up a couple of Weston Instruments Wattmeters. Now one of them is a model 905, and you can actually see that Wattmeter in use in my previous video where I'm using it to measure the output power from an audio amplifier that I'm repairing. Now that Wattmeter worked perfectly fine as I received it, so I was able to start using it right away. Now this model that we're looking at in front of us right here is a model 432, and it definitely has a problem, and I'll get into exactly what that issue is in just a moment. Now these are passive wattmeters, the 905 and also this model 432, and that's because they obtain the power that they need to operate from the circuit they're connected to. There's no active components inside these wattmeters. A very ingenious design on how they actually function. There are some power resistors inside, and that's why there's this vent that you can see up on the top right here. Dissipates a little bit of heat when it's in actual use, but again, they're a passive design. So as you know, wattage is the product of voltage and current, so this is basically multiplying those two inputs and giving us a reading. And they work on both AC and DC. So again, very ingenious design on how they're able to incorporate all of that into a single meter, and again, no active components. Now these meters are about, I would say, 60 years old, both the 905 and the 432, and for that age, the meter looks to be in very good condition. Again, it does not function correctly, so there is something going on with it, but there's no physical damage on the outside of the meter. You can see on the sides over here, the terminals look to be in very good shape. The handle is actually still in good shape, but tip is anything that's older vintage like this. Really don't use these handles because you can pick this up and the handle can rip or tear on that pivot right there, and then the thing goes on the floor and you got big problems. So be cautious on using these older handles to carry them around. It's better just to pick up the instrument. Now you can see on the back of the instrument right here, there are a couple screws and also these rubber feet. It's supposed to be used in the upright position, but if you want to lay it down, there are some bumpers or little feet right here. You can see, let me zoom you in a little bit closer. You can see on here. So what Weston did on any of these meters of this age or this era, and there were several different types, they all use a similar case style, but they are DC voltmeters, amp meters, and so forth. On any of these meters, they have these screws with a seal on the head. So you can see right here, this has like a black sealant on here, and also this one. These have never been removed since it left the factory, so that's a very good sign. There's some resistors in the back here, and there'd be probably some calibration areas back there as well. And you can see over here the current inputs right here. Okay. And I don't know if I mentioned yet, I think over here, this is the voltage input. You can see there's the common 100 volt and 200 volt inputs. So depending on which voltage input you use, that determines which scale that you're actually going to read on the front. And if we look here, you can see the two scales. So this top scale, although it says kilowatts, this is actually, you multiply the scale out, of course, so you have 0 to 1,000 watts or 1 kilowatt full scale on the top range, and then the bottom scale is 0 to 500 watts. Now you can see that the meter is not resting on 0, and if I try to turn this 0 adjustment right here, it doesn't actually 0 the mechanism inside, so that's of course a concern, but that's not the only problem, and I'll demonstrate what the other issue is in just a moment. And you can see right here, I think someone probably did try to open this up at one point, and then luckily I think they stopped, and they probably didn't open it up all the way, because you can see there's a screw missing right here, but this screw over here still has the factory sealant in place, so no one has removed that one yet. So I don't think this meter was actually opened up. So maybe someone started to open it here and then thought maybe they shouldn't. So let me make some connections to the wattmeter and I'll demonstrate what the actual problem is. Alright, I have the wattmeter connected to my DC power supply and also to my dyno load. Pardon the fan noise in the background, that's on the dyno load so that it can dissipate the power as just heat, so it's acting like a resistive load. So the connections that are made to this wattmeter, you can see an example diagram right here. This is referencing that model 905, but the connections are the same for this wattmeter as well. So it's basically that the current is flowing through the wattmeter, and that's on the amps connection, and then the volts connection is basically measuring the voltage potential across the source. So the meter then knows the current flow and it knows the voltage, and the product of those two gives us the wattage. Alright, so the power supply is turned on, and of course we can see that there's no indication here, and that would be normal because voltage but no current means that there is no power. So I'll go ahead and turn on the dyno load. Might be hearing a little bit of a hum in the background, so the power supply definitely has a load on it. So it's 50 volts and it's a 2 amp load, so that should be 100 watts, and we can see there's been absolutely no indication on that meter. So again, it should be showing 100 watts right now. So if I take the meter and I move it a little bit like so, maybe even tap it a little bit, there we go. And it's pretty close to the 100 watts, so we're reading on the bottom scale. So it's pretty close. Of course, the calibration is probably off and it's not zeroed correctly, so no concern on that. You can see that how it wiggles there, no problem. I mean, it easily is moving there when I'm tilting the meter back. But if I go like this, okay, turn it back there. Now I'm going to shut the dyno load off. You can see how it hangs up. So it doesn't really want to move correctly. And then if I turn this back a little bit, then it kind of falls back down to that 0 point. So definitely something sticking or hanging up in the movement on this needle or the mechanism that's inside of here. So basically when it's tilted at about a 45-degree angle back, it seems to function correctly, but when it sits correct, upright like this, it hangs up. It's kind of an interesting problem because, I don't know if something, has been damaged or from, it doesn't look like it was ever dropped or something like that. And I can't imagine that the mechanism is actually worn out. So I'm curious what actually is hanging up inside of here and causing this problem. If I turn this at a bit of an angle like so, that, and then reach up here and turn this on, like so again, so it pops up again there. It definitely wants to hang up on the bottom edge of the scale there. Keep it tilted and turn it back off. You can see it falls back down. So, and then of course now we're below 0. It should come resting right at 0. So I think the next thing that we need to do is try and take this front cover off, and that means breaking the seal, but again, it doesn't work, so really no harm in doing that. So I'll get this removed and then take a closer look at the inside of the meter and see if we can determine what the problem is. Okay, I've removed the screws that hold the front cover in place, and that just lifts right off, so set that aside. And look how beautifully constructed that meter is. Very, very nice quality. So after examining the various components in here, I'm noticing that there's a lot of excessive clearance in the pivot point that's right under this little bracket that comes across here. So this screw right in the middle should set the clearance in that pivot point. So if I just very gently touch the needle right here, kind of see how much clearance, there's like a side-to-side movement in there. Right there, see how that's moving in there? Really seems to be excessive, and I think what's happening is that that movement is causing the needle and the coil that it's attached to it to drag or bump against something else. So I'll take a closer look at this adjustment and see if that corrects the problem. Now the slot that you see right here, that's part of the 0 adjustment. So on the front cover, there's the 0 adjustment right here, which has little pin on the back side right there, and that pin fits into that slot, and that just causes that to rotate back and forth, and then that sets the 0 resting point. So the way that these meters actually function, if you look down in here, you can see there's this brownish colored wire. That's the current carrying coil. So that coil is attached to these 2 current terminals on the side. So that's one coil, but the other coil is inside of that position 90 degrees. So you can think of the current coil wound this way, and then the voltage coil is wound 90 degrees like that. And the voltage coil is attached to the shaft that goes from this pivot point to the other pivot point on the other side, and then of course the needle is attached to that. So the magnetic field that is set up between the voltage coil and the current coil, the interaction of those two through the magnetic field is what causes the deflection of the meter, or of the needle. Now, there's no permanent magnet in this meter, so compare that to a traditional DC voltmeter where you have a permanent magnet and then you have a very, very finely wound coil that's attached to the needle, and the interaction between that coil's magnetism and then the permanent magnet causes the deflection. But again, in here, there is no permanent magnet. And that makes sense because if you think, let's say you put voltage to this but have no current flow, so let's say it's an open circuit. Well, then you would have no power in that circuit. So you would have voltage going to the voltage coil, and it would create a magnetism, but it would have nothing to react against because there's no current flowing. So you'd get no deflection on the meter, and that's, of course, would be correct. Now, if you look on the front right here, you can see it says 6,615 and then 13,230. Those are resistance values that were factory calibrated and from the factory adjustment. They're on the voltage coil. So let's see how accurate those still are. Move this to the side a little bit here, grab my meter. Again, this meter is probably at least 60 years old. And let's see how the accuracy is looking. Cut that out a little bit there. Glare on the screen there. See that? So if I go from the common voltage terminal right here to this terminal right there, so we have 6.606 k ohms, and the marked value is 6.615. Very, very close. Doesn't look like any issues there. Very, very close after all these years. And the other one, so 13.22 k ohms, and the marked value is 13.230 k ohms. Again, very close. I don't think that should be any issue whatsoever. I think if the meter movement or the needle is not hanging up in there, then I think this should be quite accurate. So let me take a look at that adjustment, and then I'll be back. All right, well, as you can see, the meter is now in a state of total and complete disassembly. So what I found is that this adjustment screw right here didn't completely solve the issue. So this mechanism right here, if we take a look, very delicate, that adjustment screw right here changes the placement of the pivot point. You can see this shaft that runs all the way through and comes up there, so the end of that shaft has a needle point to it, and it goes into a conical shape in the end of that screw. So it's basically setting the clearance and the tension that presses down into that shaft, because this other end right here isn't really adjustable, but it appears that there's like maybe a spring thrust washer, because there's a spring tension on that shaft. If you actually press the shaft downward, there's spring tension on it. So what I did is I made the adjustment on this center screw so that it just brought in some tension onto that shaft. It's just pressing it down a little bit. Now, it's pretty cool that it's in this state of disassembly, because you can actually see the inside workings. And as I previously mentioned, that current coil, the large coil on the outside right here. And if I wiggle this back and forth, you can see the movement of that inside voltage coil right there. That moves back and forth. And that voltage coil, very, very fine wire on that coil, and the electrical connection to that coil is through those very delicate two springs that are up in the top right there. Those actually make the electrical connection. So the actual interference, what I discovered is that down in the bottom here, you can see when it moves, see that paddle right there? See that moving piece down in there, and then also on the other side as it moves back and forth? So those are vanes or paddles that are in these cavities, and these covers right here go on the top portion right there. So what's happening is, as those move through this space in here, it's causing air pressure on one side to compress a little bit, and there's holes, very precision type holes that are in those vanes, and the air is able to move to the other side, but it does so in a controlled way. And that acts as a viscous, dampening effect on the meter movement. So right now you can see when it's like this, it's very prone to moving. You can see how that needle is bouncing around like so, and that wouldn't be desirable for the actual operation of the the instrument. So those, again, these are just adding a dampening effect. So pretty cool how they incorporate that, just using the air as a viscous type fluid, although it's not actually a fluid, but it has that effect. So the interference though was those paddles were bumping on the top of these covers. All right, so these covers where they fit over the top of those paddles in there seem to be rubbing a little bit. And when each cover has two screws that holds it in place, and you can see the right there and then over there where the threaded holes are. Same on the other side. When I loosened those screws a little bit, immediately things freed up. So what I did is I set the adjustment on this top screw so that it pressed this shaft down, and it set the clearance on these vanes or impellers just below this surface level of this casting. And on one side that seemed to be okay, it did the trick, but on the other side it still seemed to be up just a little bit, and I was able to very carefully bend the arm that holds that, and when I say bend, I'm using that term very loosely, just press it down a little bit, and it looks like it set it down just below the surface level. So I'm going to put those top covers back on again and try it, and I think it should be clear, and if not, I'll have to make a little bit further adjustment, but that's the point that it's at right now. So I'll go ahead and get those covers on and then see if the clearance issue is taken care of. There were no issues with this coil in the inside. Nothing was rubbing or bumping in there. These springs seem to be in good shape. The pivot point obviously works very well. You can see how easily that wants to move when you just wiggle this a little bit like that. And of course, removing this from the actual case involved desoldering these two wires right here. These are for the voltage coil. And then you can see there's 4 screws that hold this whole assembly down inside. And then this outer shield that I had mentioned is to protect from external magnetic fields. You can see how many stacks or layers of that steel pieces are in there to build that up. So those two, and you would just remove those. There's a little stud and a nut on each side, and so those are able to be removed and just taken out of position, and then that gives access down into the bottom. So pretty straightforward to disassemble it, but extremely delicate. Obviously, it's a very, very delicate mechanism to work on. You know, if you bump something just in the wrong place, it could absolutely ruin it. So I will continue with placing those covers back on those cavities down there, and then let's see if it's functioning correctly. Okay, I've reinstalled the 2 covers that go over the paddles that are in the bottom portion of this casting. So you can see the cover right there, and then the cover back there. And it looks like the issue is now taken care of, so there's no more interference. So if I very carefully just bump this needle right here, this is the counterweight on the back side of the needle, and you can see it very nicely moves with no binding whatsoever. So that's looking very good at this point. And if I turn it, more of the normal operating position, of course, would be positioned like so. And if I just very carefully bump the needle like that, you can see it moves very easily and doesn't bind up or drag or has any hesitation in that movement. And if I move the zero adjust, that you can see how that would move the needle up and down, so that zero adjust mechanism is working correctly as well. So I think the issue is taken care of. I'll get this reinstalled into the housing, get everything put back together again, and then let's electrically test it and see if it's working correctly, and let's make sure that it is in fact accurate. So I'll make some connections with some external digital multimeters so that we can take measurements of voltage and current and then compare the readings that we're getting to the wattage reading that the meter is showing us and make sure that the accuracy is where it should be. Alright, the Wattmeter is almost completely reassembled. I just need to get the dial plate installed up here, and then of course the front cover. And when you're reinstalling this front cover, you want to make sure that this pin right here that's on that zero adjustment screw right there, you want to make sure that that pin lines up with this slot. The easiest way to do that is to position this at the 12 o'clock position, just visually straight up there, and then you can position this pin also at the 12 o'clock position. Things will line up very easily that way. And now that everything is reassembled to this point, we can see that the meter movement is still very free in here. There's no binding. When I very gently bump that, you can see it easily moves, has that very nice smooth movement to it, so no issues whatsoever. And looking very good down in there. So I'll continue with the reassembly and then we'll check the calibration. Okay, the Wattmeter is now completely reassembled, so let's check it out and see if it's accurate. So you'll notice that the Wattmeter is resting on its back, okay, it's on the horizontal plane. And I think I previously mentioned that the Wattmeters would be used on the vertical or sitting upright. That's not actually correct. If we take a look at this 905 series Weston Wattmeter instruction manual, you can see right here that the instruments are generally intended to be used on the horizontal position and that they could be ordered specially to be used in the vertical position. So I imagine that this meter, again, this is a model 432, but it's constructed internally the same as a 905 series Wattmeter. So because they work the same, I'm sure this one was intended to be used on this horizontal position, which I don't mind at all because it's very easy to use it that way on the bench. It's very easy to see the dial this way. All right, so the test setup that I have here, the Fluke 85.3 is measuring the current, so it's just connected in series with the current terminal, so we'll be able to monitor the current that's flowing through this meter, and then the current is going up to my dyno load, and I'll show you that in a moment. That's just acting as the adjustable load, or basically you could think of it as a variable resistance. And the voltmeter over here on the Fluke 289 is measuring the voltage that is on the voltage terminals over here on the Wattmeter. And you can see my power supply right now is set to 50 volts DC. If everything looks good on the DC voltage test, then we'll move to AC voltage because, again, these meters work on both DC and AC. So So as we know, wattage is the product of voltage and current. So if this is set to 50 volts and I have 1 amp flowing through it, we should have 50 watts. So the voltage terminals over here, I'm connected to the lower voltage setting, meaning that we're reading this bottom scale, okay? So the bottom scale goes from 0 to 500 watts. Because it says kilowatts, that's 0, and then we have 0.05 or 50 watts. 0.1 is 100 watts. You're just multiplying that scale out, all right? So again, we're reading on the bottom scale. And let me just move the camera up here for sake of completeness. You can see the dyno load that I'm using is all the way up here, although it looks rather high in the camera. It's just at arm's reach on the bench, and right up there is the dyno load, so I'll be able to adjust the current that flows through the wattmeter, and it's just being dissipated as heat. That's why the fan is running up there. Let you move back down here, and I'll just keep the camera focused on the meters. Really nothing to see up there on the dyno load. The camera movement here. All right, switch this on, and let's take a look here. If we go 1 amp, increase this, very close there to 1 amp, right there. I'd say that's pretty close. So we're right about 50 volts, 49.9, close enough. Right about 1 amp, that says 1002 milliamps or 1 amp, and looking very good. That's right on 50 watts, so exactly where it should be. And again, you'll notice that we had voltage being applied over here, but no current flow, and when, in that case, it was reading at 0. Only when the current started flowing through here did the meter actually begin to indicate. And that, again, I was mentioning how the two coils interact, and it takes current through both of the internal coils in here to cause a deflection on that meter. Let's increase this a little bit more. Go over here, let's go up to 2 amps. Close to 2 amps right there. Nudge that back up a little bit closer there. Let's see. Pretty close right there. This dropped down just a little bit because of losses in the test leads. That's all right. It's very close still. And over here, it's right on 100 watts. So that looks excellent. No problems there. 50 times 2, it's 100. So looks like it's working. The accuracy looks really, really good over there. Let's change the voltage. So if I go back down to 1 amp, and I'll go over here to the power supply and we'll increase the voltage. I'll go up to 100 volts. All the way up there, let's see, pretty close to 100. Now the current is staying the same because that dyno load is in the constant current mode, so it's holding at 1 amp because that's where it's adjusted to. If it was just a power resistor, that you were using as a load, of course that current would be increasing, but in this case, again, it's in the constant current mode. So we're very close to 100 volts right there, and you can see the current is still basically at 1 amp, very close to that. And we're very close to the 1. It looks like it's reading just a touch high. Let me make sure. You need to lower this down. Let's go. That voltage maybe a little bit closer. The power supply over here is an older style with a knob adjustment on it. It's not a digital input, so pardon the time it takes to make these adjustments here. Power supply is a big Sorensen DCR 150-6B, a very heavy power supply. Nudge this down just a little bit there. That's pretty close there. We've got 100 volts and 1 amp. It's very close. I would say it's maybe about the width of the needle above 100 watts. So very, very close. Really can't complain about that. I mean, that calibration for all these years that this instrument, has been around, it looks very, very close. So I'm very happy with that result. It's looking pretty good. So if I actually increase this up to 2 amps, we should have 200 watts. Very close here. Pretty close there. And yeah, again, it's about a needle width above 200 when I look at it here. I don't know, let's see, I'm looking at the camera. It's pretty close as well. You get a straight view looking down on the meter. How it's intended to be viewed. Again, it's looking like it's just just a tiny bit above that 200. So again, really close. Of course, we are drawing just a little over 2 amps. Down right there. That's pretty close to 2 amps right there. Actually, that changed it when that went down closer to the 2 amps. That needle set right in. It's exactly resting perfectly on 200 watts. So that looks really good. No issues whatsoever with that. So let me make some changes on the configuration here, and we'll check this out on AC voltage. Okay, for the test with AC voltage, I've reconfigured so that the wattmeter is measuring on the high voltage side. So now we're reading on this top scale. So this is 0, 100 watts, 200 watts, and so forth over to 1 kilowatt. And you can see that I have 47.207 volts. All right, so kind of an odd voltage value, and I'll explain why in just a moment. Basically 60 hertz, 59.998 hertz. And you can see it's right about 2.1 amps, 2.098. It's of course reading in milliamps, so 2098 milliamps. So these values are kind of odd looking, but we are getting right at 100 watts, very close to that, and it makes sense because I have a 500 watt incandescent lamp connected that's rated 500 watts at 130 volts, I believe. I think it's a 130 volt lamp, not 120 volt. But nonetheless, that's acting as the resistive load. So when the voltages drop down, you start to get into these kind of unusual numbers here. But I basically adjusted the voltage to create 100 watts and just to see if that was accurate, and in fact it is. So if we take the calculator here and we take 47.207, multiply it by 2.1 amps, and you can see on the calculator 99.1347. So 99 watts, and that is right at the 100 watt mark. So looking very good. No issues with that calibration. It's looking really close. Again, almost probably 60 years old, and really hasn't changed all that much. So let me increase the current a little bit more. I'll do so by just increasing that voltage. That'll cause more current to flow because again, it's an incandescent lamp. And let's take this up to maybe something closer to 200 watts and see if that is remaining accurate. Okay, I've increased the voltage. You can see it's now 73.67 volts, and we're getting 2.7 amps or 2700 milliamps, and it's right on the 200 watt mark. Let's see if that works correctly. So if we take 73.67, multiply it by 2.7, and not too bad, look at that, 198.909. So 198 watts, 199, and right on, looking very good. Okay, I've increased the voltage a little bit higher, so we're getting a 400 watt indication over here. So let's see if these numbers work out to give us 400 watts. So the voltage is indicating 115.1. Multiply that by 3.46, let's say 2, fluctuating there just a little bit, and we get 398 watts, almost about 398 and a half, pretty close to that. So very close to that 400 watt mark. So I really can't fault the accuracy on this wattmeter. It looks really good. Now you can see that the frequency has been right at 60 hertz for all of these tests, but let's increase that frequency and see if the accuracy remains continuous. Now as the frequency increases, it is expected that eventually the accuracy will drop off, but I'm curious to see if we can go to say 400 hertz or maybe even 1000 hertz, and what would the accuracy be at. So again, let me make some adjustments and we'll take a look. Okay, I've changed the AC power source to 400 hertz, so you can see 399.99, so right at 400 hertz. And I made the adjustment so that the wattmeter would indicate 350 watts. So when this is pointing at 350, we get 105.84 volts at 3.309 amps, or 3,309 milliamps. So let's multiply those out and see if the wattage makes sense. So we have 105.83, multiply that by 3.309, not too bad at all. Look at that, 350 watts, right on. And again, we're reading that top scale, so it's 300, 400, and it's exactly in the middle. So it clearly works well at 400 hertz. Let's increase that a little bit higher. Alright, I adjusted the AC power source to 1000 Hertz, so you can see it's 999.9, so right at 1000 Hertz. So let's see if these numbers work out to the 350 watt reading that we're getting over here. So we have 105.34 volts, multiply that by 3.301, 347.7 watts. And this is indicating very, very close to that 350 watt mark, so not bad at all. Very, very close in accuracy. So because this is working well at 1000 Hertz, it means that this watt meter will work very well in testing audio equipment, because you can put a 1000 Hertz tone or a 1 kilohertz tone into an audio amplifier and then run the output into an 8 ohm dummy load. Use this watt meter to measure or monitor the wattage that's coming out of a power amplifier. So it'll work very well for that application, and in fact you can see that being done in my previous video where I'm using the 905 series watt meter for that exact purpose. And so of course, if you're following along with this demonstration and working on one of these watt meters and have a setup like this, you're absolutely doing so at your own risk. Keep that in mind. There's obviously exposed voltage on all of these terminals, and you can see we're at 105 volts. You would not want to come in contact with anything around here. So obviously common sense, and take care. Know the safety precautions necessary when working on something like this. The AC power source I'm using is isolated on its output, but again, you would not want to come in contact across the AC line on here. Very, very dangerous. So take care and be safe if you're working on something like this. Alright, the repairs on the Weston Instruments Model 432 watt meter are now complete. The meter is working very well, and I'll definitely be able to incorporate it into future work that's done on the bench. So if you enjoyed this video, please remember to give it a thumbs up, and if you're enjoying the videos on this channel, remember to subscribe. There'll be plenty more videos coming in the near future. All things electronics, repairs, testing, how-tos. So you'll definitely want to subscribe so you don't miss out on any of those upcoming videos. So until next time, take care, thanks for watching, and goodbye for now.